Okay, hello everyone, and welcome back. Today we're going to look at absolute value inequalities, all right, in two variables. Again, we've looked at absolute value, and we looked at linear inequalities. Well, now we're going to look at absolute value inequalities. And our objective is to graph and solve an absolute value inequality in two variables, okay? And how do you solve it? You graph it. If you remember inequalities, we shade. The essential question, how do we solve an absolute value inequality? Guys, just a review. Again, an inequality, it looks just like an equation, except instead of an equal sign, it's got one of those greater than, less than signs, an inequality sign, an inequality symbol, okay? We solved it by graphing it. We solved a linear inequality by graphing it. All right, all the points in the shaded area, any of those points, made the inequality true. It acted as a solution. Remember, we had to decide, though, if the boundary line itself, if it was dotted or solid, in other words, the points on the line, are they part of the solution or not? And we had to decide, do we shade above or below that boundary line? Now, in absolute value inequality, it kind of acts the same. All right, it looks just like an absolute value equation, which we've graphed. We looked at them before. We moved them around with the HK, found the vertex. But instead of an equal sign, it has the inequality sign, right? Greater than, less than, or it might be greater than or equal to, or it might be less than or equal to. And again, we solve an absolute value inequality in two variables by graphing it. All right? The shaded part is the solution. And again, we have to decide if the boundary line is dotted or solid. Is the line itself a part of the solution or not? And we have to decide whether to shade above or below that boundary line. So again, an absolute value inequality, they kind of look like there's 6 examples there. It's a region in a coordinate plane, an XY plane with a V-shaped boundary. That's what an absolute value inequality is. Again, guys, the boundary itself, there. Guys, the boundary of an absolute value, it separates the solutions from the non-solutions. That's what it does, just like when we worked with linear inequalities. And points on that boundary line itself, they may be a part of the solution, or they may not be a part of the solution. If it's dotted, they're not a part of the solution. And two variables has a graph. That's a region of the coordinate plane with a V-shaped boundary. Now you can determine which side to shade, again, using a test point. You can check whether that point satisfies the inequality. If it does, then shade that side. If it doesn't, then shade the other side. However, we're going to use only slope-intercept form. So you can just look and see, is it pointing at the y or pointing away from the y? As an example, again, first you graph it. Okay, and we can graph it in Desmos too. Once you graph it, you have to decide, is the boundary line shaded, or is the boundary line dotted or solid? And then you shade above or below, depending on which way. Do you see how here the sign is pointing away from the y? So we shade above. And just to review, guys, remember, when you multiply or divide an inequality by a negative number, you have to flip the sign around. Okay, we won't be doing much of that. I just want to remind you of it. Guys, also we can start with a graph and then write the inequality. Look at the vertex. Find where the vertex is. And then just write it in HK form, in absolute value form. Just make sure that you get the sign correct. Right here, it's above, so it's pointing away from the Y. It's a dotted line. All right? So it's greater than, but not equal to. Only greater than. All right, just a quick summary. In graphing an absolute inequality in two variables is very similar to graphing a linear inequality. The graph of the absolute value inequality contains all the points on one side of the V-shaped boundary and may or may not include the points on the boundary. All right, the graph of the solution, it's one side or the other. And it may or may not include the boundary line, the V-shaped line. All right, that's it. Y'all can go ahead and take a look at the homework check. We'll do it in class, I'm sure. And part of the homework check is not just the essential question, but it's those 3 vocabulary words that are covered in this PowerPoint slideshow, okay? All right, thanks.